Is that cool?
It's 53.
Who asked me that?
It's 53?
Yes. Or 2 halves. It's because they have to type it like this.
Oh, yeah.
And then when it's more than just to the square, you have to type it in individually. So you can
I wasn't right.
yeah, you have 53. Oh, you were right. It's still wrong.
Type it in like that.
What?
I know there was a time. Oh, yeah, no problem. That time is
What page is this?
All right, so it says to do two things on 66. It says plot this. If the red is h of x, what's that going to do to it? This is one of the freakier shifts, one of the easier ones to forget. Remember, when it's in with the variable, it is the opposite of what it looks like. Careful. Won't do anything in the outputs. It'll do something in the inputs. All the inputs will be 3 times smaller than they used to be. All right, so 1/3 is big. So now it goes, at 3 it goes to 0. Now it's going to go to 0 at 1. So it's going to compress it along this, into the 0. I don't know if it'll make that sound. You guys with me? Because now if x is 1, what am I actually plugging into h? 3. And at 3, what's it do? It goes to 0. So now it's going to do that at 1 instead. X can be 1/3 as big because the first thing I do to it is triple it. So now this happened about almost at 2, so now it's going to happen almost at 2/3. Very concerned faces, I like that. Do it again. So again, this will take all the inputs, and they could all be 1/3 as big as they used to be to have the same output. So where did it used to hit the top? When it was almost 2. That's what it looks like in the book to me anyway. So now when's it going to hit the top? When it's almost 2/3. 0 is 0. You can't do. Everything's coming towards that, right? So he's going to stay right where he is. And the same thing over here. It used to be at 3 that went to 0. Now it's going to be at -1. And this is about the same idea here. So now it's going to look like. It's a spring that's been compressed. Very small bit of spring, but no well. All right. Yeah. No, let's not be too optimistic. It goes up to 2.6.
What section is this stuff in?
That was sorry, 2.5. Yeah, thank you. So the other one was y equals h of 1/3. That's the one that's going to make everything become 3 times bigger. So my scale suddenly is not good enough. Oh, too bad. Yeah.
And I have one more on
Yeah.
one more question. And if h had a coefficient, that would make it longer or
Look at you. Don't read my brain. Where would I have to put this in order for it to go this way? Stretch this way? Where would I have to put that 3? On the outside.
On the outside.
If it looked like this,
What's the trouble?
it takes all the outputs of what they used to be and triples them. And that's what stretch this way. How we doing? Okay. So, what was the question again?
Who knows? I don't know. This one, I can't factor. So this is a quadratic.
Somebody give me a non-visual reason why this is not a function.
This is a circle.
Doesn't pass horizontal.
Sounds like it's
lines.
probably visual.
Vertical lines.
I said circle. I didn't draw you. No, I mean
Oh, the line.
mathematical reason, like a purely algebraic reason.
Has the line
Purely algebraic.
It does not pass the.
And how would you see that there's more than one output for an input? That's visual. If it's going to be a function, I should be able to get y equal one thing. If I get, for example, y equal two things, it's not a function. So when I do try to solve this, I do get plus or minus. So for any given input, I get two outputs. That's not good. So that's how I can see it from an equation now. I don't need necessarily the graph. Graph is easier, I understand. But you won't actually be able to graph every function you see, or every relation you see. So I need to have some algebraic way of telling if it's a function or not. Now this, dear God, please, do not let me see any more of this. Right? Please stop it. What's wrong with that? Some of you guys know I'm talking directly to you. I won't call you out.
I don't know what's wrong with that.
Can't take a square root. Square root can't go across a negative, right? Square root is a power, and you can't distribute a power across a plus or a minus. They don't play well together. Yeah. That's the whole thing. It's the same thing as saying x plus 2 squared is x squared plus 4. It's actually the same mistake. It's, in this case, it would be saying 9 minus x squared to the 1/2 equals 9 to the 1/2 minus x squared to the 1/2. You cannot distribute across a minus, you with me? Because exponents, of course, are based on multiplication. They play well. They can distribute across multiplication all day. No problem, because that's what they're based on. What goes across, what would actually distribute here? A coefficient. Why? Because coefficients are based on addition. So it plays well with addition. Exponents are not based on addition. They don't play well. It involves more complicated stuff there. Is that cool? And that's exactly why you can't do that. And that's exactly, this is a power. This is a 1/2 power. So it's got the same problems any power does. Cool. Yeah.
So that algebraically is not a function because it has plus or minus?
Yep.
So that means 2x's to the 1y?
And that's not the only way you could see, but right now that's really the only way we would see two outputs. That's the most obvious way is y equals two things. For any given x, y is two things. That's exactly the opposite of the definition.
Okay, and that's because you squared both sides. When you square it, you want to add a plus or minus, right?
Yeah, that plus or minus has got to be there for the operation of square rooting something. Yeah. I'll be careful. The minute I start saying that, I see this.
I'm not listening.
What's wrong with that? I asked for the positive root. So why are you giving me the negative root, right? So if I have something sitting there, I haven't taken a root yet. I want all roots, not just the positive root. And that's why when you take a square root, you've got to give me both the positive and the negative root. You guys see the difference?
Yes.
If I just have a square root sitting there, I've already decided that I only want the positive root. If you come and do a square root in something, nobody's telling you which one. You better give me both. Okay, cool. Yeah. All right, one last time. Never again. How can I say it? Let's see. So the difference between this and this is that this is a specific number. It's a positive number. I just want to know what that root of 9 is, that positive root of 9. This is what squared is 9. And there's more than one thing that you square to get 9. So That plus or minus, another way to look at it is just to save your ass from, you could do this the long way, and then factor it, and then you see your two answers, right? The shortcut involves some understanding that that needs to be there to cover for the fact that that's what you would get when you go this way. Okay, cool, cool, cool. So now is the time to get something off your chest. If you saw something in the quiz, you're like, why did I get that wrong or something? Yeah.
You were. That's not a quiz. That's pre-calc.
I thought I was doing quiz corrections.
You were?
Oh, yeah. Okay.
Okay.
I was doing quiz too.
Stop confusing me.
So we did one sort of like that earlier. Let me see what I have. No, let's just make one up. So it's something like
These are
this.
my notes.
See if I make it the same thing. Yeah.
I have no idea, no. I can't do it now. I've been trying for an hour.
Now, thankfully I didn't see too much of this.
Okay.
But don't
Learn how to
allow
do
this. I saw maybe 2 people doing something like this. That's really optimistic. I appreciate trying to make those the same, but you have to do it legally, and you're only allowed to multiply or divide top and bottom, right?
Right.
1/3 is not the same thing as 2/4. You can't just add 1 to the top and bottom and everything's good. Or else everything equals 0, because it just keeps subtracting 1 until you get to everything's 0. No good.
Let's learn how to do this.
So what the hell do I do here then?
Times it by x plus 2.
Yeah, so the shortcut, is there anything to factor?
7.
I've got 3 pieces here, right? So they all need all 3. So there's 2 ways to do this, and the more direct route is just to multiply by all 3 of these. Why am I allowed to do it? Because there's an equation here. So some of you guys didn't ever do that, and you got to this step where there was stuff all over, and it was equal to something, and you're like, oh. Or the equal sign went away somewhere, or suddenly wasn't an equation anymore, but it's got to be an equation. Let me do it the other way, actually, than what I just said. One way to do this is to just give everybody what they're missing. Is that cool? What's he missing?
X
X and an X plus 2. As long as they multiply to the top and the bottom by the same thing, it's completely legal. This needs a 7 and an X, right? It's not minus there. All right, so I saw this. Now, the beautiful thing, the minute you do this, these can all go in. Why?
Because it's an equation.
Yeah, because I can just multiply both sides by them, they're done. Or another way to look at it, I made all the bottoms the same, now I can just focus on the tops. That's kind of a shortcut way to think about it, but once you get all the bottoms the same, I can multiply by that bottom, and they die. Because it's an equation. Now, if I multiply by the bottom in the first place, I just pick up what I don't already have. He has an X, so he picks up these 2 things. He has a 7, and so forth. That's the quicker way to do that. Okay. So now I've got a much nicer looking thing. I've got 14x plus 28
Oh, that's beautiful.
minus 5x squared. Now I'm going to make a mistake here. What mistake did I make? I pretty much told you.
Parentheses.
No.
Around the
Minus
5x
10.
squared.
Minus 10.
That minus
Yeah,
has to go
it
through.
carries through, yep.
There. So that mistake threw a few people off. And then over here, I just get 21. And that looks a lot nicer. I might have to do quadratic. Considering I just made this totally up out of nowhere, I almost definitely will have to do quadratic.
Maybe not.
Add 4, subtract, and then 28, so subtract. And then who knows? That looks like
horrible.
I'd be really surprised if that factored. Totally does, Jeff. Into 23. 23, no. This is my other class that I was joking about Jim Carrey's movie. Have you guys seen the movie, the number 23? That is slightly freaky. Anyway. I still don't want to see that, Jeff. Thank you. Is that cool? I mean, quadratic after that's not a big deal, right? Should not be. It should not be a big deal if you get complex, though. If you do the work and you just stop and say no real solution, that's fine for right now, because we haven't really incorporated complex too much yet. But if I get a complex number from quadratic, you just put an I in there, it shouldn't be a big deal. Yeah. From the quiz? Let's see. Considering there's 4 different versions of this thing, to be fair, let me just make one up. So this should be pretty much like what 3A was for everybody. So the first thing to realize, let me just ask this, how many terms are there? There are 2 terms. 1, 2. I always forget that could be a stumbling block here, but I didn't see too much evidence of that, but I just want to make sure everybody understood. There's 2 terms. I do not. And I did see one person doing this, which is kind of cool, but kind of not, because here you shouldn't want to multiply anything. So I understood you're trying to figure out Pascal's triangle down to whatever power you had, but no need for that here. Please, dear God. What numbers can come out of both?
Z minus 11.
I like that. So 9. How many y's can come out?
Y5.
5. How many z minus 11s can come out?
6.
Good, because that's the least I see. And then you just write what's left. 2. All the y's are gone.
1.
I got one of these things.
3.
3.
Y3.
Y3.
None.
And none of those. And then you just clean up the inside. Distribute that too. It's basically exactly the way that problem should work for you. And this is another level. If you can start realizing that is exactly the same problem as what you have on 3A. They're exactly the same problem. If you don't have that gut reaction of, oh, hey, Jeff, I don't know, Y's and Z's. If you can get past that and say, yeah, I see. Okay, that's huge in mathematics. You start realizing that there are only a certain number of types of problems, and every problem is not different. Yeah?
Is it okay without solving the brackets first? Can we just take the common factor? The common
That's what we did.
Yeah, I mean without solving. Let's say we solved the bracket and then we did the way you did it, like solving the brackets first, like Z7 and minus 77, and then Z6 minus 66.
Okay. This would involve so much more than that. 2 things. It's to a power, so it's not times 7. And the other thing is I'd have to write this 7 times and start foiling like mad. Right? It's going to be disgusting. It's going to have Z7, Z6, Z5, Z4. Don't do that to yourself. Yeah, I don't know the form for a 7th power factoring problem. Right? We don't memorize that. Because it's not easy in any way, sense, or form. Okay. I don't know what you're saying. Negative 11 to the first?
Yeah, doesn't that have an exponent of negative 11?
This one,
Yeah, it does.
So why can't you
Quadratic.
multiply the negative 7 to that?
right?
The 7 to that, sure. And then you end up with negative 11 to the 1 times 7 is negative 11 to the 7th. Eventually, you still got to FOIL this thing out. Right? You can't bring that 7 in. You can't distribute that power there. Yeah. All right. I'm waiting for the honest person to go, Jeff, can you do the quiz? Because you're just, bouncing around, and there we go. There it is.
Can you do one with the third?
So here's one like 1A. There, and we made it worse. So again, I mean, this is a problem that I expect my Math 88, my Math 90, maybe even my Math 110 to have a little trouble. I do not expect my 176 students to have any trouble with this, especially the level of trouble I saw. So I desperately want to be realistic with you with what you need to be able to do to succeed in this class. I am not going to cover PEMDAS in depth. I'm just going to point out that you need to go freaking bone up on this stuff. What's the first step here?
Exponent.
Yeah.
Oh,
Parentheses. So I do not, we just spoke about the fact that you cannot distribute that. So I saw a lot of like 2 minus 4 cubes becoming 8 minus 64 somehow. You'd have to FOIL it out. And actually I did see a few people, in a way this is better. I saw a few people doing this. But please, dear God, please notice how better is not good.
It took forever.
It's sort of like hit me with a little hammer instead of the big hammer, that's better. I'm still getting hit by a hammer. It's not good. This is not good. Because what am I cubing? I'm cubing -3. So of course I do that if I can first. So I got 11. And I saw a few too many of this. What's wrong with that? I mean, you got... Or is there... 11 minus 6 is 5, Jeff. That's what I was taught. What's wrong with that? It's not 11 minus 6. It's 11 minus... I don't know yet.
53.
Right? I don't subtract before I do all this
Until
stuff.
there.
You guys with me though? I'm hoping it was just first quiz jitters. You kind of were like doing too fast. It was the first problem, and normally the first problems people make sillier mistakes very often. Yeah.
Did you cancel the 11?
Yeah, the very first you could do that. Yep. I just want to see if anybody saw it. So you saw it. So you could cancel the 11s right off the bat, but we won't. Let's go. What do you do first here? So this is
Minus.
-3. Now is this divided by 8? Yeah, I'm only dividing by 2. It's not fair to suddenly divide by 8. I'm dividing by 2 and then multiply
There
by
it
4.
is.
That's not
I
the
got
same
it.
thing as divided by 8. You don't multiply before you divide. I
That's
don't
my
care if
answer.
it's PEMDAS.
I
It
got
could have
it.
been PEDBASA,
I got it.
right? Did I already tell you guys that? So it's PEMDAS, and in fact I write it like this just to be a little more clear. Definitely, definitely, as it comes, as it comes. But it could have just as easily been PEDMSA. Because you do MD and AS as it comes. But what's easier to say? PEMDAS. What do most teachers write? That, which drives me insane, because then students learn M before D. Except after E. But this is as it comes, this is as it comes, right? That just screws people up. Okay. So here you get 11 minus 6 times -27. Now here you can be a little smart about it. You can do 6 times -27, but then you're going to divide by 2 anyway. So 6 divided by 2 is 3 times -27 is
31.
times 81. So it's negative, so it makes it negative become a plus. So that's all this here. 6 times 27 is something. Divided by 2 is 3 times 27, which is 81. The negatives cancel. Now you just got to do 81
So
times
close.
4.
So close.
The 11s cancel, so you get 3.
I just was wrong. I just
You
did
could
this
have,
wrong.
at the beginning, killed the 11s.
So you have to 4 divided by 4 times 5.
40 divided by 4 times 5.
Do you guys see that?
Yes.
Minus 5 minus
Yeah.
3 minus.
The cubes, yeah.
Positive 53. Why is this number so ridiculous? Did you get a ridiculous number?
I'll do one even uglier. So this is one like 3b.
3B.
First thing is if it has two terms, you have to figure out is it a difference of squares or some difference of cubes. So basically, can you cut everything in half or cut everything in thirds? Here I can cut everything in thirds. And when I say that, I mean multiplicatively. 8 divided by 3, but 8 cut in 3 multiplicatively is 222. 125 is 555. Good. So this will be 5 W2, 5 W2, 5 W2. And then this will be 2 YZ, 2 YZ, 2 YZ. However you want to write that, or if you want to write that, I don't care. Just a student of mine several years ago did that, and I saw them like, that's a cool idea. I think I'll teach it like that. There you go. So what do I put here? Little dude, big dude? Yeah. 5W squared plus 2YZ. 25 W to the 4. So overall you get 6 W's, thank God, and 125, thank God. You can check your stuff as you go. Make sure you get what you're supposed to get. At the end would be
4,
in the middle, what sign?
minus.
Minus, the opposite of this. And then just multiply those. So you get 10 W squared YZ. It's a much uglier example than what you have on your quiz.
Yeah.
But it works the exact same way. Yeah. 1C? I think we did one like that already. Didn't we? Yeah, sure. Let me see. So in keeping with the theme of making these uglier, it's only uglier because they added a pair of variables, right? The A's. I highly suggest you simplify the inside first. So I have less stuff to do this too. Does that make sense? You could bring the -3 in, but you can't leave these poor guys out. And if you haven't reduced them yet, it makes it look like it's going to be worse than it really is. So I would want to reduce stuff first. What do you hear?
4/3.
Yeah, 4/3. What happens here? Those 7x's go, and those 4x's go. So 7x's over 4x's leaves you with x3. Those two z's go up, and those stay there. I saw way too much of like the 28 going down just because it's in front of something with a negative power. The 28 is to a first power. It doesn't go anywhere. 28 is to a positive power. There's no reason for it to flip. The negative power is only applying to that variable. How are we doing so far?
So if it's a negative, it goes down. Positive.
Stays. If it's a negative, it switches.
Okay.
If it's a positive, it's happy where it is. I mean, that's another way to look at it. It doesn't like it up there, so it goes down. That doesn't like it up there, so it goes up. Those three z's are happy. They stay there. Cool. And the A's, how many A's are left? 2 on the bottom because that's where there were more. Do you guys see that? Yeah.
You just subtract down.
Yeah, you could. -4 minus -7 is -4 plus 7, which is 3. Sure. I personally don't like doing that. And plus I teach my students because it's so easy to make a negative mistake. In general, but especially in this case when you're trying to do it in your head, it's really easy to make a negative mistake. And I see it all the time. I see this become 1. No, it's not 1. It's 3 minus -2, which is 3 plus 2, which is 5. What 2 things does this tell me to do? Flip. And cube. And I haven't cubed it yet, so now I can cube it. And what do I get there? 27, a to the 6, 64, x to the 9. See, I don't know what to do. Z to the
-5 minus -3.
15. Sorry.
Is
Blink.
-5.
That's really going fast.
3, which is
Logan's Heroes? Anybody? Yeah. 3C? Okay.
That's right.
That's how it goes. That's perfect.
Oh my gosh.
Okay. I'm going to show you actually how well, let's first see if it works. Then I'll show you how I created that problem. This problem should work. We'll find out. All right. What's the first step here? Yeah, take that into account. And I need factors of that make the middle term. That sounds like the normal first step if the 10 wouldn't have been there. I find factors of the last 2 that equal the middle 2. The only difference here is that I have to take that into account. Yeah. -50 and +3 will work there. You guys see that? They multiply to be -150 and they add to be -47. But what's the next step after that? Good. Break the middle dude up. Using those as coefficients. Because what that does is it guarantees that the thing I can do now will work. And what thing can I do now? Group. Because now I've got 4 terms that group. Grouping should be relatively easy. So real quick, I do like to show you how I create problems. So what I did, I don't know if you guys noticed, or if you just were turning away, like, whenever he's done making a problem, I'll take a look. But I put those down first, and then I was like, deep in thought for a minute. I'm tired, I can't do this in my head. And then I finally came up with a number. What I was doing was, 10 is 10 and 1, and 5 times 2. 15 is 3 times 5, or 15 times 1. So I decided to do 3 and 5, 10 and 1. 10 times 5 is 50. 1 times 3 is 3. If I make it different signs, it'll make 47. And then I decided to make it negative, so the bigger one would be negative. I don't know if you guys follow me.
Why did I get it right?
So really, what numbers could I have put there? I could have picked 15 and 1 and 5 and 2. And then I would have done 30 and 5. And 30 minus 5 is 25. So a 25 here would work. I didn't want to do that because I didn't want it to be reducible. See how I can take a 5 out? Do you guys kind of follow? So I know in my Math 110 book, I don't know if this book does the same thing, they actually asked that question, what would work here? They said plus BA. And they said, what could be B? Just like that. It's weird. What could B be? So it could be any combination. It could have been 150 and 1. It could have been 149. Or negative 149. Any combination of multiplying these factors and adding them together. Because that's exactly what happens here. I get a 3 and a negative 50. You have to add them together to get this. So I'm just doing the exact same thing with all the possible things that could be there to make it work. There's my, where do you go, 50 and 3. Or I could do 15 and 10. Like a 5 there would have worked. So forth. So hopefully that makes a little bit of sense.
Totally knew how to do that and forgot.
I forgot I was going to wear my vodka shirt today. I forgot about that.
There's always that they multiply negative 15 by 10. And then I forgot what was there. So I do remember.
Yeah, negative 150, and then find the factors to make this. Yeah. Yeah.
Did you show us an example of doing minimum points of the function?
Are we going to get a break here?
Like on the calculator?
Not from a book. I mean, just I know the facts about it, but I don't know how to do it. Like minimum and maximum point, 2.3.
Oh, they
No,
give you...
Sorry, that's 2.4. So that's
Yeah, it's not that one.
that's-
I'm pretty sure it's 2.3 you're talking about.
yeah, it's 2.3. Getting information from the graph.
So, either they have to give you the graph, right? They have to give it to you. So they give you a graph like this. I can find the max and the min. You know, they have to give me a decent scale so I can kind of see what it is. I mean, that's and the min is exactly what you hoped it'd be. It would be the minimum. It's called a local min because this goes lower and this goes lower, but locally that's the lowest, right? So if this was like a profit function, it's a profit function for a company. Obviously, I want to try to get here. That seems to be the most profit my company can make. And in real world, it's a moving target. Because this equation is based on demand, supply, desires, how well your commercial's doing, all this kind of stuff. All these things come in and making this equation. So you keep trying to hit that target, and then the next day it moved it a little bit. So you have these people called financial analysts that make, my friend Sean used to work for Dell, and he got out of there just in time. And he's got like 5 kids, so thankfully he's making, over $100,000 a year. But you make a lot of money because that would drive me insane. I love my math, but my God, that would drive me a little crazy. But that's why they make so much money. It's a moving target trying to figure out what price to set and all these different things about how to try to capture that maximum profit. And then the next hour, it's moved a little bit on you. So you're like, oh shit. So I don't envy him. Especially with 5 kids. Yeah.
If a question asks for local maximum and minimum, should we write the whole form like x and y or just y?
It depends on the question. If they say, where is the max or the min, that's an x. If they say, what is the max or min value, that's the y.
So where is x equals?
Where is it is x. What is it is y. X's find things. Y's tell you what they are there. Yeah.
There's 2 ways of finding the minimum and maximum. Run over, what is it?
Rise over run?
Rise over run.
That's the slope of a line.
Yeah. You cannot
So-
find it.
Do I have another blank one?
Yes.
Yep. Sure. Yeah.
I noticed the answers in the book for questions like that would say y equals this when x equals blah, blah, blah. If we put the local maximum at that point where that is that wrong?
Well, the way they word it, I'm looking at one example. The way they word this question is find all the local maximum values. The values will be y. But they also say, and the value of x at which each occurs. So that would be giving both the x and the y piece. So it depends on the way it's worded.
But if you do it as a point where it shows this would be the x value and this would be the y value, and that's the thing, would that be wrong than saying y equals this when x equals this?
I understand if you do that, and I probably won't take the points off. But it is a bit different, depending on the way the question's asked. If I say, where does the maximum profit occur? You're not going to tell me what the profit is. You're going to tell me the x value. How many widgets do we have to sell? Or whatever the imaginary thing is that you're selling nowadays. Right, in business class. Used to be widgets. Any business people here? Business majors? Business majors? All right, you're my kind of people. Sorry. Business and I do not get along. Although I have taught business calculus, and that's sort of a conflict.
What are 76 and 78?
What did I do wrong here?
So on section 2.2, it says find a function whose graph is the given curve. And it says the line segment joining the point this to this. Another way to say it is find the equation of the line that does that. So y equals mx plus p. Yeah. I think they're all, the first two are linear. And then the last two are like the top half of the circle. How would you get the function that describes the top half of this circle? We actually did this earlier. So who was paying attention?
So,
How can I tell that this is not a function? What did we do earlier to show that this is not a function by itself?
line
Solve for y. So if I want the equation for the top half of the circle, I'm going to get to a point where I get plus or minus, and which one am I going to pick? Plus. So that would be a function, wouldn't it? The top half of the circle is a function. Why? Because it passes the
horizontal.
vertical. Horizontal is coming up in section 2.7. But it passes the vertical line test. So that's one way to remove the problem from something, is just to identify, no, I just want the top part. Well, now it's a function, because now you took away the repeating part, the part that died on the vertical line test. Yeah?
What if you want the bottom half?
Then you would pick the
negative.
negative. Yeah, that's all. So this would be, if you solve this, you'll get 9 minus x minus 4 squared. Square root, plus or minus, and then that's the last step would be minus 2. So you just pick which one you want.
Plus.
Pick the positive if you want the top half, pick the negative if you want the bottom half.
Maybe this question may sound like like a personal question, but on the paper I see like the practice test. I don't see any word problems. Do you think we're gonna get tested on word problems or no?
That is pretty personal. Number 7 I would consider to be. I mean, I could certainly make a word problem that has more words to it. But number 7 is basically a word problem, right?
You don't need to do that.
I mean, you've definitely seen worse word problems in your homework. Hopefully. Yeah. Well, that's the kind of word problem I give you is that one, yeah.
I've got questions on our particular test. should I just like come up to you after class or whatever? Because I don't have a, come up with values and I can see on this test where there'd be like x minus this times x minus that. Number 2A, so I have 7. Are you marking out because I didn't factor in that quadratic deal or because I only said 7 was it?
Oh, so you end up being right, but I need to see that process of eliminating the answer. You should get 2 possible answers and one of them go away.
When I run it through, so should I write in, if that, let's say that case were to happen again, should I write in this case, then go underneath and do the square root of 2 plus 2 plus 4 would not equal 2, so that you can see.
Yeah, yeah, you could do that. Cool. Whenever you got a radical equation with square roots in and stuff, you got to check your answer because, and we talked about this a little bit, when you square both sides, you lose information about what the signs used to be, so you might get answers that don't work in the original equation. That's what's called extraneous roots. Sounds like a dental procedure, but math is giving the answers to the intermediate problem, not to the original problem, because that's all it can do. It can just give you what's going on right then. So you got to check your answers, make sure. And you got to show me that process. Don't just not even write it down, because then I'm like, did he even get that? I know it's not part of the answer, but I need to see you getting it and then saying no. Yeah.
I can. I can get a D.
Yeah, so
It's almost the same.
I think I'm done. I do them all?
Yeah, there will be at least one problem asking you to find a few things using the calculator. Okay. Just like what we did in class, finding like max or min, or finding the roots, or finding the intersections. Right. So if you want, we could do a few of those right now. Yeah, sure. It's review day, man.
I knew this one too, dang it.
Yep. I always do 3 bonus questions. And then normally each worth 2 points, so you could get 106. Yeah, if you make corrections in your quiz and you get all the corrections right and then you get 106 on the test, your quiz is now 106. That's the way it works, yeah. All right. So, if you need, I'm going to borrow one. We're just going to do this, unless there's more questions. I have a few. If you need one, you want to try this at home, or just sit and watch. Let's see if we can do this here. I'm thinking not. There we go. How you doing there? You're almost... All right, you got 10 minutes. Yeah. Just give it back. All right, so let's try this out. Let's do 8x to the 3rd power plus 4x squared minus 10x plus 3. All right, let's see what happens. Oh, of course, my window's all freaky, which is good. So when you do this and you hit graph and you get something like that, I can see my graph, but it's obviously not really easy to see. So I hit zoom 6, just kind of start off with my standard window. All right. And then I can adjust it as I need to. And to me, one of the coolest parts of this is that zoom box. Remember, did I show you that zoom box?
Yes.
Because then I can see everything I'm interested in, like any roots or any maxes or mins, they're all happening like right here. So I can hit zoom 1. Just go over and down a bit, hit enter, and then that's the corner of my zoom box here. Let me see. This is so exciting. Okay. And now it's just going to focus on the key parts. Neato. Oh, wait. That's interesting. Now, this is a real technical point, but I'm going to give myself a little more room. It's a little weird when the x-axis is so far down, because then the questions they ask will sometimes overlap it. So I'm going to go to Window and just make my y min maybe negative 4. Just to give me a little more room here. You guys see that? Did you have to do that? No. I have to tell you that? No. Oh. So let's say I want to know the max, the local max. Of course, you should be able to point it out. Where does a local max seem to occur? Almost what value? Where does it occur?
Negative.
Yeah, I'm just moving that cursor accidentally. So it's just negative 1 there, right? Just a little bit less than negative 1, a little bit more than there.
It's like between
Cool.
negative 1 and negative.
Well, let's get it exactly. How do I do that?
You go trace.
Good. Second, trace to get into calc. And then,
Left
good,
down.
number 4, maximum. And it asks you those 3 questions. So you want to go to the left of it. You want to go to the right of it. And then you want to get right on top of it. Bam. So just like we thought, just a little bit near negative 1. And it also gives me the output value there. Cool. All right. That's exciting. So you can do the same thing for the min. And I'm kind of curious about the min because it looks like it hits the axis. That'd be kind of neat. That was the min.
It does.
So the min, you go down to it. So you get right on top of it. You hit left a couple times for the left bound. Right a few times for the right bound, and then right on top of it. And there's a good example of, what is it trying to tell me here?
0.
Yeah, it's trying to say 0. Time sent to the negative 11 is really, really tiny. It's trying to say 0. Now here, this is interesting. I'm not sure if it's really trying to say 0.5 or not, but I think it is. So it looks to be right at 1/2. That is the minimum. In calculus, you'll actually learn how to do this by hand. Find the max and the min by hand. And that sounds like it's going to be just heinous, but it's so not. It's just silly how easy it is. You'll see. Well, some of you will see. The rest of you will forever wonder. All right, how do I find this root? Root way over here. Otherwise known as the,
Intercept.
what do you call it here? The root is also known as the what of the function? I like it, the x-intercept, which is also known as the 0 of the function. Cool, so that tells you when you go to second calc, when you hit number 2, that's how you find your x-intercepts. You use the 0. And of course, it's putting me way back over there. Let's just double check this one. Left bound, right bound, yes. There you go. Now you get verification of the earlier thing. It is 0.50. So that minimum just happened to also be the x-intercept, which is kind of cool, considering I completely made that equation up out of nowhere. It's freaky. How are we doing that? Can you guys do all that on your own? Now the only other thing would be finding the intercept of intersection of two equations. So if I put in here, I don't know, E2. Let's see, 4x plus 3. So how many solutions are there to the equation 4x plus 3 equals 8x cubed plus 4x squared minus 10x plus 3? Looks to be 3 solutions, right? How do you find, like, I don't know, this solution here?
Intercept.
Second calc, go to intersect. And remember the shortcut. Now that's kind of a bad example because they've written all over it. So let's do this one here. The shortcut is just go as close as you can to it. Hit enter, enter, enter. So what's it trying to say here?
Close to 0.
Yeah, the intersect at 0, 3 is what it's trying to say. Which again is a little unexpected. It is negative 0. It's like they used to have those billboards that would tell you the speed and direction of the wind. And it would say 0 west. And like, okay, the wind is facing in the west direction, but it's not moving anywhere. It's a little weird. So anyway, that's sort of like negative 0. So you can find all 3 of these intersections if you needed to. So expect maybe at least two or so questions that would have you doing these kind of things on the calculator. Yeah.
For the 0 function, like use that x-intercept as opposed to the other.
No, I have to do each. If I wanted all my intersections, I have to do each one. Do the intersect, enter, enter, enter on one. Do the intersect, enter, enter on another one, and then just keep moving my cursor. I've got to do each of them separately. I just picked one. And again, the one here, see how it's hidden underneath this wording? So again, I just go to my window and make my Y min a little bit bigger, which just lifts it up a little bit, so now it's not going to be overwritten by that wording. So that happens up here. So now if I want to find it, I can see it still now. And another thing, I'm not sure, a lot of you guys are kind of new to this, or a few of you guys are new. Up and down bounces you between functions. If I have one function on the screen, up and down doesn't do shit. So if any of you guys have a function that's really kind of steep and you're like pushing the, why is my cursor not going anywhere? Because there's no other function for it to bounce to. Left and right moves, right? X is where you are, so left and right changes X, so it changes where you are. So if I want to find that one, I just go right on top of the answer. Enter, enter, enter. Bam. Yeah.
For the test, like you also write down like negative 1.5% of that, or just kind of round, or
Yeah, you get round, that's fine. When in doubt, round a couple places. Yeah. This one's a little freaky because maybe it was negative 1.596. No, I'm not going to make you draw the graph. Yeah. You just write down the answer.
Do we have to turn it into 2.7 homework also, or just?
Not yet, for the next
That's
test.
next
2.7 homework will be for the next test. You only have to do up to 2.6 homework. And I can't remember, I think on WebAssign I just...
It's due on WebAssign.
2.7? All right, I got to remember to go and drag it out of there.
So 2.6.
Say again? 12E? D. We did that one earlier. The one that's 3xa minus 3a. Yeah, we did that one up on the board. And you got an answer key too, right? Okay. Now, if you guys have no more questions, you can head out. That's fine. I see a lot of you guys like, dude. So, obviously.